record on this computer. Does anybody have any questions with regards to Django queries? No. And we have this cheat sheet for you. It's a good resource. So let's jump into Django validations, reviewing that. So when you go to your first job and are working on like a real production grade application that has, you know, tens of thousands, if not hundreds or millions of users, you will be, your website, your application will be under attack pretty consistently. And there's layers of protection that we have to implement to ensure that the data that is coming into our database is the type of data that we want. So we don't want any bad data that might corrupt our database or anything like that. And there's generally 3 layers of data integrity or data protection. That's the interface layer, the model layer, and the database layer. Their interface layer, or the outer layer, is what you see on the screen in the CRUD app, or like on the actual web page, like in your forms when you're filling out, you know, your social security, a form that you have to type in your social security number in, or some credit card information in. There's the outer layer. So there's some form validations in the front end that run some logic that ensure that, you know, only numbers can be input into that form and submitted in that form, or only text, or exclude some specific type of data, or like email, like ensure it's a valid email address. And that's like the first layer. So there's some, when you're typing in a form, there's some method being called when you submit it that is running, ensuring that that form has the right data in it. And if somehow some hackers get past that by getting into your app or getting past the front end and start to like injecting data, then there's the model layer. And this is like the layer we're going to be working on today. This is where, before we actually save, like data got past this first interface, or the outer layer, or the interface layer, then before the data is actually saved, on the back end, it's running some additional logic that's checking that this specific data is what we want it to be. And that's what we're going to be working on today with validators, or validations. And at the very core is where we're actually defining the specific data type for those specific fields, like ensuring that a date field only accepts date time, or date time, or like some field is a Boolean field, but it only accepts a true or false value, or a char field that only accepts text. Like it can't accept numbers or anything like that. That's like at the core database layer. And if somehow they get past that and they save some corrupted data, or they save some data that your database shouldn't have in it, you're kind of SOL at that point. Does anybody have any questions about like the 3 layers of data integrity and checking, that ensuring that the data that's being submitted into your database is the data that you intend to get put there?
I just have a quick question about that. So maybe I missed this, but since Django kind of implements the database through the model, like that's what writes your SQL, are those 2 layers kind of combined in Django, the model and database layer, or are they still separate?
No, yeah. So that's what we've been kind of doing. So that's where you're actually defining your model. Like, all right, model swim records, where first name is a models.char field. That's what this is at the core.
Got it. Okay.
Yep. All right. So let's go into this challenge. This challenge, it starts out easy and then it gets really difficult. Like when I redid it, I was like, oh shit! Like it took me like an hour of Googling and researching on how to complete, what was it, the last test spec. All right. So I've got my Django validations. I'm currently in my Django validations project. I've got the swim records app. So let's just what we know about Django and Django apps and Django projects. Inside of our settings, we have our swim records. This is the installed app. This is already here for us. That's pretty much it. Let's go down. Where's the database? So it looks like it's a Postgres database. It's probably going to do some logic in creating our database for us. Great. So inside of our swim records, we have tests. So we have all these tests that we need to pass. Inside of our models, we already pretty much have all of our fields written for us. We just might have to extend those fields or add some additional arguments or parameters to those fields. So let's just go down here. So the first setup, create a virtual environment, and then install the requirements.txt file. Should all be pretty familiar with this routine, these steps. So I'm in my Django project. I need to python-make venv. I'm going to make a virtual environment. All right. So it's making a virtual environment. My virtual environment directory was just created. Great. Now I need to go into my virtual environment. All right. Source venv, which is the name of my virtual environment, /bin/activate. So now I'm in my virtual environment. I'm going to zoom in. There we go. Is that better? All right. Next, I need to install this requirements.txt file. Those are all the requirements I need right now. I can do Python, or nope, it's pip install -r requirements, and I'm installing all the necessary requirements. Does anybody have any questions about that process? We're pretty much going to be redoing that process over and over again when we already have a Django app that we want to clone down from our another repository.
So we can do an alias for that, like python-m vim. We can just make like is it just alias and then you type what you want and then the command, or how do you do that where you do an alias in the command line? I remember he showed us once. I just can't remember where in the video.
We can touch on that later, but yeah, you can create an alias as long as you ensure that your virtual environment or like making a virtual environment, like create an alias for making a virtual environment.
Yeah, so basically I would create the alias for like creating the virtual environment, but I'd want to keep whatever name I want separate. So I would just type in like VV or whatever I want and then the name,
okay.
right?
Yeah. So yeah, I think you can do that in your bash profile. Just typing, I think it's just type alias equals the command you want to be. But yeah, we can touch on that later.
Okay.
All right. So I created a virtual environment. I entered into this virtual environment, and then I installed the required modules. Now I can just run Python manage.py test to run all the test specs right here. And I want to just fail fast. So that's just, it stops at the first time it fails. So instead of running all of them, creating test database. All right, let's bring this up. Swim records, failed swim test records, unexpected indent. Cool. So let's open up our models, close that, split the screen. I'm gonna actually bring this over here. So I've got my models on the left, a swim record. Oh, what's that? That's not supposed to be there. Yeah, or my tests on the right and my models on the left. So it says pass delete when you start writing validations. So I'm going to actually run that test again. So, all right, it looks like it failed. So it ran 5 tests. So it looks like the first 5 tests passed for whatever reason, probably because I have this pass in here. But let's delete this and run this first test here. So validate first name is present, validates presence of the first name. Cool. All right, so let's run this test right now. Python manage.py. Oh no, it says, well, a bunch of stuff happened. 0, not null, primary key, first name, varchar, none, not whatever. So the char field, let's add a max length because we should, and let's just do 255. So if you just do a char field and you don't care about the max length and you just have it like that, it will fail because it needs a max length. It like needs a parameter in there for it to actually pass. Let's run that again. Python manage.py. Let's do yes. All right, I ran the first test. So it ran 2 tests. The first one passed by the green dot, and then it said test validate last name is present. So we can pretty much do the same thing here. Max length equals 255. And clear. Let's run that again. All right, 3 tests passed. Says validate team name present. Let's go ahead and pretty straightforward so far. Max length equals 255. Clear. Let's run that again. 4 tests ran, so we passed. Where'd it go? Passed the first 3 tests by those showing by those green dots, and the 4th test we get an error. Validate relay is present. All right, I'm just gonna refresh, undo that. I'm not quite sure how the Boolean field Django example. Do I have to pass in anything? What is it? Boolean default value. That's a lot of stuff. I don't know if I want all that. Like Geeks for Greeks. Model field reference. Boolean field. It looks like it only accepts options. So I don't necessarily have to have anything in here. So like where's char field? Char field must have a single argument of max length. All right, let's see if this works. Clear. Fail fast. 5 tests ran. Cool, we completed the first 5, or ran the first 5 tests, passed the first 4. It says validate stroke. So it says validates that the stroke is one of front crawl, butterfly, breast, back, or freestyle. So let's go back to Django. So challenge includes 1 model swim records, follow the test records, adding any missing validations using the provided Django. All right. Whoop. There we go. So char field, let's do a max length, so we need a max length. Let's do, I don't know, 100. Let's run that again. See if it passes. Initially, still no. It's passing in doggy paddle in the char field, and it's not passing. So we have these validators in Django. There's a bunch of built-in validators, and there's a bunch of ones we have to create on our own. So just looking at this example, is there like a built-in validator that I can pass in something into list validator? What is this? I've never seen. Separation returns a regex validator instance that ensures a string consists of integers separated by sep. It allows negative integers. Okay, that's not what we need. So integer field, looks like we need to create our own custom validator. And the syntax looks like validators equals validate even, which comes up here, which looks like a method someone wrote outside of the class. So I'm actually just gonna, all right, so if I can do max length 100 and then do validators. All right, validators equals, let's call it, what is it? Validate stroke. And then outside of the model, the class, let's create validate stroke method. And it takes in a stroke, and we can do stroke list and of the available strokes, which are right here. I'm just going to have an array. And I can say if stroke, let's do stroke type. Type not in stroke list. I need to, how does it says? If raise validation error, it also looks like I have to import that. Raise validation error. And then I can do a message. So I need to do an F string. It's going to work. So I want to type in. So if I look here, like the swim record, it should say doggy paddle is not a valid stroke. So it's actually doggy paddle stroke type is not a valid stroke. See if this works. All right. So it ran the first 6 tests. It worked. Validate. Yep.
Real quick, the this type of function doesn't have a an argument in the actual like class or under the class variables.
Right here.
That was. Does it need to be put in there?
No. So Django is smart enough to know that, like, hey, if you're putting a validator in this specific field, it assumes that you're testing the value of stroke. So you don't have to put in like an argument stroke or some argument in there. So it's smart enough to know that.
Okay, cool.
Yeah.
I'm on board.
Is there a like a best practice for where we write the validator functions? Like I hadn't written the same place you do, just above the class, but is that normal?
Yeah, that's normal. Or you can put it in like a different file of like validators.py file and import that. But a small application like this, you can include all your validators there. I like including it in the same models and like above it, just because I can look at the model and be like, okay, here are all the different validators associated with that model. But as your application scales, you might want to separate them out into like a separate file or something.
Right. Yeah, makes sense.
All right. So validate distance. Next, all right, it's an integer field. It says validate distance must be greater than or equal to 50. All right. Let's run that. Clear it. Just run that. Let's see what happens. All right. Make sure this value is greater than or equal to 50. Scroll up. Yep. So I can do I can write another validator separate, but let's just look down here, these built-in validators, to see if there's anything we have that can ensure the value is greater than or equal to something. So we have regex email validator, which is kind of nice. Validate. We have all the way down here, we have a max value validator and a min value validator. So it says class min value validator. Here's the limit value. So it takes in one argument and a message equals none initially. So raise a validation error with a code of min value if value is less than limit value. So looks like I can use this min value validator, or I can write my own. But since they already have one built in, I can just pass in this. With the minimum value, I want it to be 50. So let's clear that and run that. Uh-oh, name min value validator is not defined. All right, looks like I have to import it somewhere. How do I import validators? How to import built-in validators Django. Oh, great. So it's the same thing. Core validators. So the Django core validators module contains a list of callable validators for use with models. So I'm going to do.
Yeah, that's your import path right there that you highlighted right now.
Import, or from that import min. I'm just going to import everything from there because I might use, I don't know, I might in the future need to use something else. So I'm going to clear that. Run that again. Uh-oh, what happened? Min value. See what happened. Min value validator. Oh, looks like I need to include this part as well. There we go. Because that is a validator. Let's see if this works. There we go. Ran 7 tests. So we passed the first 6. Got an error at the 7. No future record. Does not allow records to be set in the future. So we have a date time field. And is there any built-in validators for date time, decimal, file extension? No, it doesn't look like it. It looks like we have to write our own. So let's call it validate record date. So validators equals validate record date. And up here in def, validate record date takes in the given date, and then, so if the given date is greater than, so I need to grab, what is it? The time, date time. So is it import date time? how do I grab the current time? Grab or current time in Django example.
The preferred time zone, right? Time
Is
zone.
it time zone?
Yeah, time zone. Are you importing it yet?
Not yet. So
Django says time zone out of their utilities is the way to go.
okay. So
You can pull it from your test. You can pull it from your test file. It's importing time.
Oh, is it?
Uh,
Oh, perfect. Cool. Do I even need this then? This date time?
No, actually, I think time zone is actually using the datetime library.
Okay. So I don't
But
need,
you don't need it explicitly. Yeah.
cool. So if given time, and then if I do, what is it? Time zone. What do they do in the test case?
It's dot now.
Dot now. Dot now. Invoke it. And then I can raise validation error. Let's do, like, let's say record date. Can't set record date in the future. I got stuck on one of these for probably a good 45 minutes because I forgot a period at the end of it. Clear, fail fast. All right, cool. Ran 8 tests, so we passed the first 7. Good. Now the last test. No break record before set record. Does not allow records to be broken before the record date. So it looks like it creates a swim record, and the record date is the current date, and the broken date they're passing in is the current day minus 1 day, so essentially yesterday. And it tries to save it, and then it blows up. Or then it should run this. So date time field. So my first intuition is to be like, all right, I can write a custom validator and pass in 2 arguments, right? Like I'm like, all right, def validate broken date and pass in like the record date, and then the broken date, and then be like if record date is greater or less than, record date, broken date. So yeah, if record date, what is it? Can't break record before record was set. So if record date is less than or greater than broken date, should be not data. Keep saying Borkin. Then raise the exception error. Can't break record date. So that's my first intuition, and then pass in validators. And then validate broken date. Let's see if this works. All right. Validate broken date, missing 1 required positional argument, broken date. So with these previous validators, it already knows that you're going to pass in the value that you want, or the value of the field that this validator is on. But is there a way to pass in another argument of a different field? Because that was my initial intuition, is pass in the record date and the broken date. Right, let's do that. Record broken date. Something like that. Or self, or like move this down or something like that. So like, is there a way to pass in multiple arguments into Validator Django? Have validators with parameters. Let's see, validate out of range, value. You can try writing a function which returns a function. That's not cool. Min date. Just can create values you actually want to be calling a function. This is like form validations. It's not really helpful. See if there's any pass them. See, compare dates, validators. Only get the current field's value, so it will not do what you're trying to do. However, you can add a clean method, and if you should be, overwrite your save method like that. Okay. There's a couple of ways you can do this. This is the way I did it. I just rewrote the full clean and said, I wrote it inside of here so I have access to all these methods or all these fields. So I said like, if self.record broken date is less than self.record date, raise validation error. And then it says, it looks like it's, where is it? Record broken date is inside of a dictionary. Where'd it go? Raise. So record broken date. Broken date. Colon. Says can't be. See if this works. Oh, no way. See, it says not supported between instances of none type and none type. So it looks like self.broken date and self.record date don't exist. So if they exist, then test it.
Hey Tom, I was thinking about this when I ran into that same problem. That's a case specifically for the test, right? Because that would never happen. Because all these have a null of false, so they don't allow nulls.
Right.
But in the test, it's doing some weird thing where it's kind of creating records where all the other things are somehow allowed to have no value.
Well, we have distance, record date, record broken date. So there aren't any. So yeah,
well, it's failing at test 1 right now because it's running full clean on test 1 also.
Yeah, these validators run for every single time you call full clean. It's running every single validator for every single, like each
right,
test.
So on test 1, it doesn't create a record date or record broken date, even though the null is false. But it's not realistic because it's only really happening in the test. It's not going to happen when you're making the model, right? Or making an instance or whatever it's called.
So yeah, we're saying it's running on this full clean on every single field.
Well, what I'm saying is it's failing test 1 right now because record broken date and record date doesn't exist. But that's kind of like an artifact of the test because can't really make a model without those things because it's not allowing for nulls.
So where is it failing? Because right now it's passing all the tests based off of.
Well, you just added the if you remove line 30.
Oh, right.
If
Yeah.
you remove line 30, it's gonna fail at every single test except for
That last one.
right.
Yeah.
So for a little bit of insight, what's happening in the test, they're not actually, when you create an instance of a model, it's not getting, creating an instance doesn't reflect in the database until it gets saved. So
Right.
they're just creating an instance of a model. And so that null constraint that is happening, that is set by default on the field for a date time field, that error can occur. So when you, that error can occur when you do, so I don't know what side to start from. So when you call full clean, it goes through, when you call full clean on an instance, it goes through every single field that's on that instance, one by one. And then on the field, as it's going over that field, it looks at its validators and says, what validators do you have? And it tries to run each one against that field to make sure everything is clean. As it progresses through each field, so each field validates itself with the validators you passed in. If any of them raise a validation error, it's collecting every single validation error that is thrown into a dictionary of errors, which is what you see the testing against. I don't know if that helps. That was a lot I just said. So
Right. That's not what I'm bringing up. What I'm bringing up is that like in test 1, for example, that would never work because there's no record date being made. So when you try to save, it'll bomb out anyways. Because
Jason,
The null error is only thrown when you call save and you have a field that's null, but they're not actually doing anything with the database in the first 7 tests.
that's what I'm saying.
Yeah.
This is kind of like an artifact of the test.
so the way he was talking about constraints at the database and the model layer being different things, I think that not null constraint happens at the database layer when you try to save it to the database. But when you run this code, that's just making a model, that's instantiating a model, not saving it to the database. So once you try to save, then that not null constraint would make it fail.
So this is one way I did it. There's another way, which isn't that great, but I just essentially overwrote the save method. So you can def save. So if you look, sorry, self, so I'm overriding the save method and just say, kind of putting this down here. You don't need to know that. So I'm overriding the save method here. So when it comes down here and it runs save, it's going to come up here, save. If record date is less than record broken date, raise the validation error. Otherwise, we can grab that specific object which is the parent, or the super, which is this specific object. Swim record. And it's referring to the specific swim record right here by doing the super. And then I could run the dot save on that.
Hey, Tom, I had a quick question.
Yep.
Why did you not need to call super on full clean?
I think it's just the way full clean runs, and I'm not actually accessing the record again. It's just, it already has the record in it. Like it already has this.
But when you overwrite full clean the way you did without calling super, wouldn't it only run lines 26 through 28 for every test?
Or only run lines 26 through 28.
Yeah, so full clean does other things besides just check for record broken date, that check. But when you overwrite it the way you did here, doesn't that kind of break the super full clean if you don't call it?
Probably, yeah.
Okay, I was just making sure.
I know, like, I don't know if this is the most efficient way to do it, but this is the one way I was able to get it to pass. So,
Okay, gotcha.
and I think this other way works as well. Let me bring that over. Oh, what the hell? There we go. And there was another combination I was like messing around with. They only like passed all the tests with validate stroke. If I don't know if you guys found this about choices. So this is stroke choices, takes in a tuple of like, this is kind of like front end stuff. So if you have like a select drop down, it's like what the value is versus what the front end looks like. And instead of validators, if I did choices, stroke choices, and at one of these may have worked. So that one, oh, what happened?
Yeah, like line 21, something.
Oh. Thank you.
And you have Stoke choices in line 28.
Thank you. See if this works. So that one didn't work. But if I did the full clean way, I think it should work. Actual valid. Huh. It worked before. Anyway, it's just like there has been people in the past that tried to use choices before. So, but the correct way is to use an actual validator instead of choices. Oh. So, there. Does anybody have any questions about validators? Going forward, when working in your application, you don't, like, more often than not, you won't need a validator, just like for like going forward in the course, but you can definitely implement them if you want. It's just know that they exist and they're the second layer of security before data gets put into your database.
Tom, do you see in typical code bases, I mean, it seems like overloading those built-in methods starts getting a little bit dangerous if you don't know what you're doing. Is there kind of a rule of thumb? Like def clean and def save? Because Steve and I ran into overloading the save method. So you don't have to use auto now and auto now add. People were using the save method to manage the date creation.
I don't know if there's like a rule of thumb or like a best practice of overwriting built-in methods, as long as you are ensuring that the original functionality of the save of whatever method you're writing is still meets the requirements of like what they initially intended to do, in addition to whatever additional functionality you want to implement. It's kind of like, oh, go ahead.
Is that what, I think that was Chase that was pointing at, your full clean doesn't call super, so we are
Writing
full clean when we really should be a child of full clean if we do it right. Is that right? Is that what ends up happening?
Sorry, I'm kind of confused about What do you mean
Well,
by child of full
Well,
clean?
it seems like we should be using some class inheritance there with full clean. in order
Oh,
not to overwrite the original.
right.
Right.
Yeah. Yeah. Exactly. Yeah, it'd probably be best practice to write another method, inherit all of it, full clean, and then run this. Yeah, this took me forever the first time I've done it. I got the test to pass, so that's all I really cared about at that point. Did anybody else do something different that worked?
Yeah, we just wrote a validator and stuck it in.
Oh, yeah. I still don't know why that worked.
Yeah. And I think it was Jason that was saying it was based off of record broken date being called in validation error, because that loads that field into the validation error object, which is how it knows what to field.
Okay.
So yeah, you wouldn't even have to call that full clean. Matter of fact, you could test it to change that full clean to whatever name you want. Yeah.
What was it? Validate broken record. And then did you do like a validator here?
That was the magic part of it. And you just run it just like that.
There you go.
PFM.
Well, that's probably the better way to do it. So you're not overwriting the full clean. Nice. I'm gonna